Smart contracts are self-executing contracts with the terms of the agreement directly written into code. They run on blockchain networks and automatically execute predefined actions when certain conditions are met. Smart contracts enable trustless and decentralized transactions, eliminating the need for intermediaries and providing transparency, security, and efficiency in various applications. Here's a detailed explanation of smart contracts. Let's delve into the concept. Smart contracts are digital agreements that execute automatically when specific conditions coded into them are met. These conditions are typically defined using computer code and stored on a blockchain. Once deployed on a blockchain network, smart contracts become immutable and tamper-proof, meaning their code and execution cannot be altered by any party after deployment. Now let's explore the key features. Smart contracts operate autonomously, without the need for intermediaries or human intervention. Once deployed, they execute according to their predetermined logic and rules. Smart contracts run on blockchain networks, which are decentralized and distributed across a network of nodes. This decentralization ensures that no single entity has control over the execution of the contract, enhancing security and transparency. Smart contracts eliminate the need for trust between parties involved in a transaction. Participants can rely on the cryptographic security and consensus mechanisms of the blockchain to ensure the integrity and enforceability of the contract. Smart contracts are transparent, as their code and execution are publicly verifiable on the blockchain. Participants can audit the code and verify the terms and outcomes of the contract without relying on a central authority. Once deployed on the blockchain, smart contracts are immutable and cannot be modified or tampered with. This ensures that the terms of the contract remain unchanged and enforceable throughout its life cycle. Let's delve into the components of smart contracts. Smart contracts are written in programming languages specifically designed for blockchain development, such as Solidity, which is used in Ethereum, Viper, or Simplicity. The code defines the logic, rules, and conditions of the contract. Smart contracts maintain their state, which represents the current status or data associated with the contract. The state can be updated based on the execution of the contract's functions and interactions with external data or transactions. Smart contracts contain functions, or executable code segments, that define the actions or operations the contract can perform. These functions can be triggered by external transactions or messages sent to the contract. Smart contracts can emit events, which are notifications triggered by specific conditions or actions within the contract. Events provide a way for external parties to track and respond to changes in the contract's state or execution. Exploring the use cases of smart contracts reveals their versatility. Smart contracts enable various financial services, such as decentralized lending, borrowing, trading, and asset management, without relying on traditional financial intermediaries. Smart contracts facilitate supply chain management by automating processes such as product tracking, authentication, and payments based on predefined conditions and milestones. Smart contracts are used to create and manage digital assets and tokens on blockchain networks, enabling tokenization of real-world assets, securities, and assets in decentralized autonomous organizations, or DAOs. Smart contracts power DAOs, which are decentralized organizations governed by code and operated by members of a community. DAOs use smart contracts to manage governance, voting, and decision-making processes. While smart contracts offer significant advantages, they are not without challenges and considerations. Regarding security, writing secure smart contracts requires expertise in blockchain development and security best practices. Vulnerabilities in smart contract code can lead to exploits, hacks, and financial losses. In terms of scalability, blockchain networks face scalability challenges, including limited transaction throughput and high fees, which can impact the performance and adoption of smart contracts, especially in high-demand environments. On legal and regulatory compliance, smart contracts operate in a legal and regulatory gray area, as existing laws and regulations may not fully accommodate or recognize their unique features and implications. Ensuring compliance with relevant legal and regulatory requirements is essential for widespread adoption and acceptance.